Hey there. When you hear the word equilibrium, you probably think balance. In physics, it is also okay to think that way. A body is in equilibrium when there is no net force acting on it. That is, all the forces acting on the body balance out. When a force is applied to a body in one direction, it may cause the body to move or change the body's velocity. In other words, a body tends to accelerate when a force is applied to it. Therefore, we say a body is in equilibrium when the forces acting on it are such that their magnitudes and directions are exactly balanced. This means the forces do not change the motion of the body, whether it was at rest or in motion. Whenever a body is at rest and is not moving at all, we say it is in static equilibrium. Whenever a body is moving with constant velocity or rotating with constant angular velocity about a fixed axis through its center of mass, the body is said to be in dynamic equilibrium. For example, if I put a metal box on a table, then I can say the box is in static equilibrium, and it will remain on the same spot as long as no external force acts on it. The box has a weight due to the force of gravity acting downwards on it, but the box is not moving. Therefore, there has to exist an equal but opposite force that keeps the box on top of the table. This force is called the normal reaction of the table and can be represented by Fn. As long as the table can provide an equal reaction to the mass on it, the mass, or in this case, the box, will remain on the table. However, if the box had so much weight that the table could not provide the needed reaction, it will push through the table. Let's consider a slightly different scenario. If I push the box on the table from one side and it doesn't move, is that box in equilibrium? Yes. This is because an object that is not moving or rotating is in static equilibrium. Let's look at the forces acting on the box. We have the weight, the normal reaction, and the push. The box is not moving, so there has to be a force opposing the force that I applied to push. This force is the friction between the table and the box. So we see that the normal reaction balances the weight of the box, while the force of friction balances out my push. Therefore, the net force acting on the box is zero, and so it remains static. Consider a car moving at a constant velocity. The forces acting on the car are its weight, the normal reaction to the weight, the force moving it forward, and the force of friction. The weight of the car is balanced by the normal reaction of the road on the car, and the force of friction balances the force moving it forward. This kind of equilibrium is known as a translational equilibrium because the body is in equilibrium and it's moving in a straight line. If the body was rotating with constant angular velocity, we say it is in a rotational equilibrium. An example of this is when you tie a stone to a rope and swing it at a constant speed in a circular path. That is all for this lesson. Bye for now.